Hi everyone, welcome to our lecture on functions. We are going to be diving back into some programming topics for this course. So just as a friendly reminder, that means there's some pre-lecture readings that you are supposed to do. They're posted in the learning resources for this week. As a reminder, I will not be going through all of the content that's covered in those readings. So the purpose of that is to give you some familiarity with them so we can do some exercises that actually apply that knowledge instead of me just like regurgitating that knowledge to you effectively. So please take a moment to read those chapters if you have not already before we get started. All right, so with exercise 0 here, we're asked to rearrange the following bullet points, which I'm calling ingredients of a function, to write a Python function that calculates the absolute value for a floating point variable, floating point value. If I could read, it would help, wouldn't it? So just as a quick reminder, the absolute value just means that if it's a positive number, it will stay positive. If it's a negative number, it will become positive. So it just removes that negative sign. So we have a whole bunch of different ingredients that we can use here, and we're going to build up the function over on the side over here. So there's two main parts to the function that we'll need. We're going to need the function header, and then we're also going to need the function body. I will always start with the function header. I can't think of a reason why we would start with the function body unless you were refactoring some piece of code and taking some code that already existed and putting it into a function instead. So what we want to do is go through this list here and figure out, okay, well, where are the pieces that would come up for my function header? And if I scan through this here, I see my very first keyword that I need, which is def for defining. I will then need some sort of function name, which again, we want it to be very descriptive of what the function is doing. So since we're calculating an absolute value, this one here called absolute value looks very promising. We'll need some brackets and a colon, and then we'll also need a value that we're passing in or a parameter that we're passing in. So when I look at these, two options I could see for parameters would be either abs x or x. It shouldn't be this one that's negative abs x because that is actual mathematical equation where we're doing 1 times that variable name. I always start typing out the variable names with my drawing and I always regret it immediately when I start doing it. But that's okay. Since I have the solution next to me here and I want to be consistent with that, I know we're supposed to choose X for this one, but if you were given something like this on a test and you chose abs X instead, as long as you were consistent throughout your function with what you were using and it got the correct result in the end, it would be fine. So let's take those pieces and let's write our function header. So we always start out with that def or define keyword, followed by our function name, absolute value. I always do my parentheses and colon right after I do the function name because otherwise I will forget. I always forget. Python always yells at me about this. Looks like you're missing a parentheses here. Where's your bracket? What's this thing without a colon? All the time. Drives me nuts. So I do that even though I know I'm going to have to put some inputs or some parameters in between those brackets just to save my own piece when it comes to running my code. Inside those brackets are where we put that parameter that we want to pass in. These are the input or inputs to our function if we had more than one. And in this case, it would just be that abs x. So now we actually need to do the function body. And of course, we remember to tab over that function body. Sometimes remember this is called the block of code that's associated with the function. There are the instructions that the function is actually going to do in order to complete the code. And I see I already made a typo. I said, let's use X here. And then I put abs X up there. Sorry. We're going to use abs X down here to define a local variable that's going to store the value of that parameter X that we can use throughout the function. You don't always have to do this. You can just use that value X directly in the function. And there are other ways also to define this function other than what we're doing here that would be completely valid, but we need to use those ingredients that we were given. So we're going to use that variable abs x and give it that value of x. We are then going to check to see if it is less than 0, because we don't need to do anything with it if it's greater than 0. If it's already a positive number, great, we don't need to do anything. If it is less than 0, we need to flip that sign on it by multiplying it by -1. So we'll just do an if statement. We know how to do that. We learned that a while ago. So if abs x is less than 0, semicolon, then we tab over a bunch and we do abs x, give it a new value of being negative abs x. And again, this is effectively just like saying -1 times abs x, but it's just a shorthand way of doing that. Once we do that, let's just print out the value of abs x using those last few different ingredients that we still have here. So the print statement, abs x, and that's the end of it. So this function doesn't have any actual output because we aren't using that return keyword. We are just displaying some information to the console. That's okay. Not every function needs to have output, but it's very important for us to wrap our heads around that difference in the way of thinking. So our input to our function will always be in these brackets up here, and any output would be with that return statement that would happen at the very end of the function, which we'll see examples of later in this lecture. So when you are designing a function, you really, really need to sit down and think about what are the inputs going to be to this function and what would the potential outputs be to this function. So unlike thinking about what problem am I going to solve, it's what information does this function need to solve this problem. It's a little bit different of a way of thinking than we might be used to, because it's not normal necessarily for humans to think about things that way. Because we can get a lot of that information just from like context clues around us, but the computer doesn't have those context clues. We have to pass them those context clues and be very explicit about what's happening in our program. So inputs will become parameters and outputs will be indicated by that return statement that we talked about. When you're starting out, it's highly recommended that you write out the algorithm of what you want your function to do on paper. If you're not a pen and paper kind of person, that's okay. You could write it in your coding environment, but just write it out using comments in plain English first. Like for what we saw last, we would say, okay, check to see if the value is less than 0. If it is, flip the sign, then print out the result, those kinds of things. It makes it a lot easier for you to actually go through and add the code in. It's really important to do steps like that on things like exams. So if you run out of time, we can still see like the logic that you were going through. And then when you're translating something into code, every step of the way, you could write your bit of code, test it, debug it, redesign it as needed to make sure it's working, and build it up that way. It will result in a lot less headaches in the long run. All right, for exercise 1, we have this friendly function that we built up in exercise 0. We now want to write some code that is going to do the following. So what I have done is I've copied that over into my pie chart, and we are going to do the various things that it's asking us. So the very first one is we want it to calculate the absolute value of -8. So we put the code for the function at the very top of our program. Doesn't have to be at the very top, but it has to be before we call it anywhere else in our program. Otherwise, the computer will be like, what in the heck is going on here? I don't know what this random word command thing that you're trying to make me do is. I have no idea what the instructions are for this. I can't do it. It will have an absolute hissy fit. So as long as we're doing it after, it should be no problem. So for part A, sorry, you can hear my dogs squeaking on their toys in the background. I apologize. Absolute value -8. We just pass in that hard-coded value here, and then we can run this and see, look, it actually does produce the correct output. Hooray for us. That's amazing. For part B, we're going to ask the user to input a value and then get the absolute value of that value. So I'll just give it a temporary variable like x, We know how to get input from the user. We just use that input command. And I can say something like, please give me a number. And then we would just pass in that variable x to our absolute value command. And it will give us the absolute value of whatever the user types in. So if we run this, we'll still see 8 from A up there. Then we say, please give me a number. Let's do 42 because it is the meaning of life. And I get a, oh no, something is wrong. In this case, there's a type error because less than is not supported by instances of string and integer. What I forgot to do, this is a classic Kim mistake. It's okay if you make these two mistakes as well. This input command returns a string, and then I passed in a string to the absolute value here. Nowhere up here do I have it converting strings to integers. I don't say that it's going to do that in my function. I need to remember to do that when I read in that value. So let me add in that integer typecast there, rerun this program, try 42 again, and now I get 42 with no hissy fits from the computer, which is lovely. The next thing we want to try writing for C is keep asking the user to type a non-zero value and calculate the absolute value of the user input until the user types 0. So this is probably going to be a loop. We need to continue to do something until a 0 is pressed. So what I'm going to do to make this a little easier is I'm going to just comment out these other lines that we're no longer using. I copied this line where we got our initial input and I didn't. I used my Mac copy, so I'll just retype it out. We're going to get an initial input from the user. Please give me a number. And we're going to check to see if that is not 0. Then we will get the absolute value from it and ask for a new number. And we will continue to do that over and over again until the user inputs a value of 0. So when we see those until something keywords, that's usually a good indication that we're going to want a while loop. And with a while loop, we usually just want to flip that. So while x is not equal to 0, we are going to get the absolute value. Oh, come on. Of x. And then we're going to ask for a new value. Please enter another one. And we will see how this works. So I'm just going to run this. It says, please give me a number. I'll put in 8. I got a value of 8. It's asking for another one. I could put in -3. I get a value of 3. I could put in 16. I get a value of 16. And when I get 0, nothing happens. It exits after that. So that's how that while loop is working. It's allowing us to call that function within our loop to be repeated multiple times without us having to write that code over and over again. The last one we're going to do is keep asking the user to type in a non-zero value, calculate the absolute value of the user input, and exit when the user types in 0 and print an error message, expect a non-zero input. So all we need to do for this one is add a print statement after our while loop that we just had and say expected a non-zero input. We can even add a big error message to make the user feel really bad at the beginning of it. And this will only happen when this while loop quits, which only happens when we get a 0 value. So again, if we run this, we can enter a number, we could enter another number, and as soon as we enter a 0, we get that error message printed out. So that's the exact same code we had for C, just with another print statement after our while loop. All right, so let me just flip back to the slides so that we can go through this next next exercise together before we come back here to the coding. So for our next exercise, we're going to write a function called print stars that's going to print out an integer number of star signs on a single line followed by a new line. Our solution should use a while loop, and the number of star signs, n, should be a parameter. So that gives us some hints as to what we're actually going to want to do there. We are going to flip back now here to the code. There we go. And actually do this. So I'm going to just do this on the same page. I'll make a new file. So I'm just going to go up to the top, right click, new Python file. This will be chapter 14, exercise 2. And we're going to start off writing this function. So the first thing I'm going to want to do when I'm writing this function is I like to start with my header line. So I know for my header line, I need my def keyword, and then I need a function name. In this case, our function name is supposed to say print stars, and we're supposed to pass in a parameter n. You can see I have my red squiggly line after. That's PyCharm telling me, hey Kim, you forgot your semicolon or your colon. Don't forget your colon. And I didn't. After that, I'm going to add in a doc string. So remember from the textbook, doc strings are these multi-line comments that start with 3 triple double quotes and end with 3 triple double quotes. And what they're supposed to do is describe to the user what that function is doing, any inputs or parameters it takes, and any outputs that it generates. It can feel incredibly silly doing this for classes like this, really throughout university, because you're often given the content that would need to go into these types of function doc strings, because it is literally effectively what we asked you to do is what the function should do. So in this case, it will print out n number of stars to the console followed by a new line. So prints out n number of stars to the console followed by a new line. And so you'll see we don't just keep writing all the way over typically when we're doing comments, and especially doc strings. Once we get to kind of close to the end of where our screen is, we start a new line just to help with usability. You'll see that PyCharm very kindly tells me I need to define what this n parameter is, and then also says if there's anything that I'm returning, I should put it in there. We're not returning anything, so I'm just going to put a none there. And for param n, I'm going to just be the number of stars that will be printed. So that gives all the information that a user would need in order to leverage this function in their own code. Think about this as like the documentation if we were trying to figure out, say, how to use the print command or different things like that, which is really a function we've been using this whole time. It's just how do we actually use it? We don't need to know what it's doing inside. We just need to know how to use it, what it's expecting as input, and what I can expect as output. So now that we have that, all we need to do is make a loop or something similar. I would recommend a loop since we don't know exactly how many stars that we need to print out. And then we will test it out and see if it works. So because it's always going to repeat n number of times and it's not until something happens, I like to use a for loop for this. So I typically use for I in range n, that will print something out n number of times. We're going to not even use I in this, it's just a counter that Python is using in the background for us to say how many times this loop needs to execute. We will print the star value, and then we'll also add that second parameter in that just removes any new line at the end of that print statement so that we don't get them all on separate lines. And then after that for loop is complete, I will just print an empty string to get that new line that we're needing. And we can run this right now and we won't get any output because we're not actually calling this with anything. What we would need to do to test this out is actually call the function after we've defined it, print stars, and could be, let's just do 3 since that's easier to count out. And we run this, and look at that, beautiful. 1, 2, 3, and a new line. We could try it with some other values. 72, why not? I'm not counting 72 stars though. I'm going to trust that this is working. And there was a couple other examples that they wanted us to try. So we could try printing out a line of 10 stars followed by a line of 9 stars. So in order to do that, we just change this here to be 10 and this here to be 9. And if we run that, we scroll up, you'll see that we are starting to get the formations of a triangle, which is very exciting and might remind you of Code Lab. Okay, so switching back to our slides. So for exercise 3, we're going to take the print stars function to find an exercise 2 and insert some appropriate single line comments in the following code with a doc string for this following function. So what I'm going to do, I don't have this typed out inside of the PyCharm yet, so I'm actually just going to put things in here and we can put little arrows to where we would put something in here. So we first need to try to figure out what in the heck is this actually doing. We're printing something, we have a parameter n that goes into it. Great. This is the kind of code that you do get sometimes in the real world, and it's awful when it's not documented because you're like, what in the heck is going on here? And you have to spend your time and your day to try to figure it out. We then have for I in range n, print stars I. So that's going to print out a line of stars from 0 to n minus 1. So that's going to kind of look like a bit of an upside down triangle. And then we have for I in range n to 0 going down by 1 will also print stars. So then that should print out a second triangle. So I believe we should get a triangle going this way, then a triangle going that way. I actually do kind of want to just convince myself that that's what's truly happening before I what should we call it? Put all the comments in here. So we are going to put this into the code here. So I have it up on my other screen so I can see it while I'm typing. Def print underscore something. You can tell I didn't write that function because I hate underscores with a passion. I don't know why. I used to love them when I started coding, and then I became very much against them, and I just use camel case for everything. For I in range, print stars n. For I in range n0 minus 1. So remember, this is just using our fancier version of range. Gives our start, gives our stop, and then instead of going up, we're going down by 1 every time. Oh, and I put do instead of 4. My bad. 4. Print. And I did wrong thing on line 15. I'll fix that after. Should be I, not N there. Okay, so that should be all of them. I'm just going to call that function to make sure it's doing what I thought it was. Print something. We'll do 4 and just run it to see. Oh, we get it. It's a reverse of what my brain was thinking. I'm happy I ran this. It's actually making a nice little pyramid. This reminds me of Twitch when people make emoji pyramids on Twitch. If you can see that. We could change this to a bigger number if we wanted, 15. And run that. Wow. Beautiful, beautiful pyramid. So now that we have this, let's build out our doc string. So again, those triple double quotes, our definition of what this is going to do, we have to come up with that. It's not given to us in this exercise. We actually have to figure it out. And in this case, I'm going to say builds a pyramid of n stars, and yours could be slightly different than what I'm putting here. That is absolutely okay. With, sorry. How would you describe this? Let's go back to the 3 one. I wanted to do something more descriptive than just saying of n stars. it's going to be 1, 2, 3, 4, 5. 5 rows, so that should be n times 2 minus 1 rows with a peak height of, oh, and I should have done a space or a new line here, peak height of n. And so n is going to be the height of the pyramid, and return is nothing. And then so for the first for loop here, we're going to build I would call that the left half, the top of the pyramid. And then for the other for loop, we are going to build the bottom of the pyramid. So I probably should have called it something other than a pyramid and maybe called this the left and then this other part the right, but that's okay. Gets the gist of it here, which is exactly what we wanted. And again, your comments could be slightly different. That's okay. We don't mind that. We actually expect that. If we see everyone's comments looking exactly the same, it's a big hint. See, it's a big hint that potentially there might be some nefarious things going on there. All right, so for exercise 4 here, we're going to write a function that asks the user for a positive integer and then counts up and down as follows. So what's the starting value to use is 5. It then prints out 0 and 5, and then it counts up from 0 all the way to 5 and down from 5 all the way to 0. So we'll just do this on this screen. We need a function header. So we start off with that def keyword, and I'm going to call this count up, down. Why not? I want to think of a better name that's like a little snappier, but I don't know. I can't right now, so I guess that's what we're stuck with. We pass it in one value, which let's just call it n to be consistent, and I have my brackets and my semicolons. Then let's add a doc string. Less nice when I do this in a text editor because I don't get all my automatic indents and things like this. So this function will display a count up and down from n to 0. Let me move this over. Our input parameter is n, which is our starting and ending count, and our return is nothing. So now to actually do this function, I think we just need a for loop and maybe 1 or 2 additional counters. So we'll need one counter that starts at 0 and goes to 5, which we could do with our range function. But then we'll also need another variable that starts at 5 and goes down to 0, which we'll have to manage within our loop. So let's just add a variable in for that so we can start saying things like count down. We'll give it the value of n to start with, and then we can use a for loop. So for I in range n, then we just print. And I see, oh, I've already made a mistake. I bet you are all yelling at me through your computers. I forgot to tab over my function body code here. So for I in range n, I'll move this up a bit so it doesn't get too covered. I didn't want to move it up that much. I might not be able to. There we go. So for I in range n, we're going to print I plus a space plus the value of n, and that should give us that 0 to start off with, the space that we want in the middle, and then our countdown that we're on. We close that bracket, And then I just need one more line here to, oh, not n. You're really all yelling at me through your computer screens. We want to use that countdown variable we made. Derp. That's why didn't we make it? And then we want to change that countdown variable to be its value -1. And if you don't believe me that this works, that's fine. Always good to be a bit skeptical of your prof. You can throw this into PyCharm, type it out yourself, and convince yourself that it is doing what we expect here. So for exercise 5, we are going to think back to an assignment question we have. Now, if you're watching this in a later course, you might not have had this assignment question. That's okay, or it might have been in a different assignment with a different number. That's fine. The gist of it is that it was a programming question where we were converting Celsius to Fahrenheit. And so we have this sample solution here where we get the temperature in Celsius from the user, convert it into a floating point number, and then do the math down here to convert that into Fahrenheit, and then print out the Celsius as well as the Fahrenheit. And this is just using a formatted string. We don't expect you to use a formatted string. In fact, if we see it, we're probably a little bit questionable about it since we haven't gone over it in class. But you can read up more on that online if you want. We want to take this and actually write a function that takes the temperature in Celsius as an input and then converts it to Fahrenheit and returns that as an output. So if we want to just modify this here, we're going to do something like def Celsius to great spelling. And we're going to take a value that gets inputted. We can just call it n for sake of argument. I'm not going to write up the doc string in this case. Feel free to practice that on your own and check our solution that's posted inside of the course resources or the learning resources for this week. And instead we just take our value n and we're going to do that same mathematical calculation. So we can really just copy that over. F equals 1.8 times, and we passed in a value of n, or use the variable n instead of c here, but that's okay, plus 32. We could use it whatever we wanted it to. And then we just return f. And we could make this all in one line, so we could just put a return here instead. I, as you know, like to be a little bit more verbose in my programming. You can choose to do whichever one you prefer. It's all good. Whoops. And then for exercise 6, our final exercise, we'll do this over on PyCharm here. We're going to write a function that will calculate the GC content of a randomly generated DNA sequence of length n. The function should take the length of the sequence as a parameter, generate the DNA sequence, print out the generated sequence, use the loop to calculate the GC content of the sequence, and then return the GC content of the sequence. It needs to be documented with the doc strings and inline comments. So let's skip over here to PyCharm and start building this out together. So I'm going to make a new file, Python file, chapter 14, exercise 6. And then I'm going to just write all of those things that I need to do after my function header line here. So I'll start off writing that. The reason I'm doing that is because then PyCharm automatically tabs everything over for me, and I am incredibly lazy. So this is just making it a little bit easier for me. We'll call this GC content, and we're going to pass in a value of n for that. I'll also pre-start my doc string just so I don't forget to go back and do that. Then inside I'm going to add in comments that are all of those different pieces that we needed to do. So A is we're already going to be handling by taking in the length of that sequence as a parameter. We could add that in here, length of the sequence to generate, so we don't forget that. We are then going to generate a random DNA sequence. We are then going to print the DNA sequence. I like to do this just so I don't forget, because otherwise I have a very strong tendency, especially when I was in courses like this, where I'd be going through things and I would just forget to do pieces of whatever I was asked to. So if I do this and I put little like effectively stubs or to-dos into what I need to get done, I can ensure that I would get full marks on my questions, which was always my goal. Using, calculate the GC content. That's spelt wrong. I'll fix that in a second. And then we're going to return the GC content. Calculate. There we go. So our return and our doc string will be the GC content of the random sequence. If I could spell, it'd be great. And what this function actually does is it calculates the GC content of a randomly generated DNA sequence. I see there's more typos in here. That's fine. I'm just not going to worry about it at this point. So what we need to do is we need to use that random function that we learned about in our most recent assignment. So we're going to just import that to the top here so that we're able to use it within the code here. Again, I know you were also, if you took this class, in this current semester when I'm recording, we did something kind of similar on the midterm, but we weren't worried about actually using this. We just wanted to say, hey, given that this function exists somewhere out in the world, show us a code snippet that would use it. So we didn't have to worry about importing here, but if we actually wanted to use it and run code with it, we would need to include that import random at the top. It's just usually not needed for code snippets. All right, so the very first thing that we're going to do is generate our random sequence. So there's a lot of different ways that we could do this. We're going to start off by having a sequence variable that starts off to be an empty string. Then we're going to use a loop to go through for the n number of nucleotides we want. I in range n. And we're going to get a random nucleotide from using that random variable or random method that we have at the top. So to get that, all we need to do is make another variable. And we do random.choice. And then we can give it the different choices that we want it to be. So this has to be in these square brackets that we have here. And we would have A as one option, T as another option, G as a third option, and C. We will learn what these square brackets mean next week. Effectively, they're just a way for us to collect a bunch of stuff into a single variable. And then in this case, this random choice function will take one of those options that's within that variable and pick one to store in nuke. Once we have that, we can just use string concatenation to add that on. If seq equals seq plus nuke to that growing nucleotide sequence we want. And then before I go any further, I'm just going to print that sequence to make sure it works as expected. So if I ran this right now, I get issues. Why issues? Because I have a space here and it's mad that I have some indentation that it's not consistent with. When I fix that, I get nothing. And I wrote all this code and I might be really frustrated that I'm not getting anything here. But what I need to remember is I actually have to call this function. So if I want to actually see it work, we have to go GC content and then give it some value. Let's give it a value of 5 to start off with. That's easy enough to see. Usually I get some different values here. If I rerun this, I get a different random sequence, and every time I rerun it, I should see something slightly different. That's how we know this random choice method is working properly. So that clicks off this piece that we need to do and this piece. Now we need to go through the random sequence and calculate the GC content. So I probably need a GC variable that starts off with 0 that can say we haven't seen any G's or C's yet. And then I can go through that sequence that we have and say if it is a G or if it is a C, increase that variable GC by 1. So because the sequence is a string, I can just go for N in seek, and that will give me each letter individually every single time that loop repeats, if you remember from our loop lecture. Then I just need to write an if statement that says if N is equal to G or N is equal to C. And I could put these as two separate if statements as well if I wanted. Either or works. Then I just increase this variable by a value of 1. And remember how we do that is we say take the value that's currently in GC, add 1 to it, and then reassign that to that variable GC that we had before. And so that will just go through and count all of those different things here. Then we can go through and just maybe add a print statement to double check that this is working. I always like to use print statements especially after I do something like a loop or something like that, just as a gut check to make sure that things are working correctly. So in this case, we have ACATA. There's only one G or C there, so we get a value of 1. If we rerun this, we get a value of 4 because we have 4 C's and G's there. So now that we know that is working, we can comment that out. And then all we need to do here is return our GC content, which we do with our return keyword. And then we just pass in that variable that we were interested in. Oopsie. How we can double check that this is working is by wrapping our function call where we're actually calling that function in a print. That will say, take whatever is returned by this call here and display it to the console. We can also save it in a variable if we wanted and do something with it later on. We'll do lots of examples of that in like assignments and things like this. But that will just help us gut check that, hey, this is actually doing what we want it to do. So again, we see 3 of those G's and C's and a 3 is returned. If we got rid of that print statement, we wouldn't see how many G's and C's were returned by that. But see, we could also store this in a variable. And then we could do a print statement, if I could spell. The number of G's and C's is temp. And if I run that, there we go, 1. And I can keep running and keep getting my random sequences and be very excited about the different things I see on the screen. But that should give us all the information that we need there. You'll have lots of experience practicing writing functions in the upcoming assignments, the upcoming labs. You will see this on final exams. So if you are struggling, please stop by help hours and get some help. Ask some questions. We can help you through it. We will have one more programming lecture coming up. No, 2 more programming lectures. Then we're through the programming content for this course. And we'll finish it off with 2 lectures on more of the biology side of things.